Now on the second page of notes, every linear function f of x equals mx plus b, where m is not equal to 0, is a one-to-one function. Therefore, its inverse is also a function. So remember, one-to-one means that we don't have any repeating y values. It also passes a horizontal line test. So that's what one-to-one is. No repeating y values. And it passes a horizontal line test versus the vertical one. Okay, so in order to find an inverse, there's a few steps. First, just it says substitute y for f of x. Really, you're just rewriting y as f of x, or f of x as y. And then you're going to interchange x and y, so switching x and y. And then you'll solve for y in terms of x. Then we can replace y with the correct notation for inverse, which is f to the negative 1 of x. So that is a notation we'll use for inverse, is f to the negative 1 of x. Alright, then we'll check our work using composition of two functions. We haven't learned how to do that yet, but we will. Or we can graph, and then we can check with points. Alright, so let's do this first example. I'm going to show you how simple it is. So step 1 is substitute y for x. We'll do that in green. So y instead of f of x, so y equals 3x plus 4. Alright, then we're going to interchange x and y, so just switch x and y. So all you're doing, instead of y, you're writing an x. Instead of x, you're writing a y. It's that simple. Alright, then we're going to solve for y in terms of x. So this is where those literal equations come in. That page where you were solving for unknown variables. So we're going to solve for y. So I need to get y by itself. So in order to do that, we do backwards PEMDAS, get rid of your subtraction and addition first. So we've got x minus 4 equals 3y. Then we can get rid of our multiplication by dividing by 3. Alright. So we've got that y equals x minus 4 all divided by 3. Now that's not in the normal form that we see it in, y equals mx plus b. So if we want to write it in that form, notice we're dividing both terms by 3. So we have x divided by 3 minus 4 divided by 3. Or we can go one step further and write it as y equals 1/3 x minus 4/3. Any of these forms are fine. If you want it to be in a linear form, it's easier to graph. You'd want to go all the way to this y equals mx plus b form. Okay, let's look at example 2. Oh, and I apologize. I skipped step 4. We do want to go ahead and practice step 4. We're going to replace y with the correct notation. So that's f to the negative 1 of x. I just want you to get familiar with seeing that. Equals 1/3 x minus 4/3. So that would be our final. And again, you could keep it in this form or this form. It's fine. Okay, and then we can check our work using a graph. I'm going to let y'all do that in your graphing calculator. So you can graph the original and then the new graph. Okay, so we'll do this the same way. Very first step is to change f of x into a y. Substitute y for f of x. Alright, so just the exact same function. And then our second step, instead of y we're going to write x. Instead of x we're going to write y. So we're going to change both of those x's with y's. Alright, and then our final step, we're going to solve for y, or solve in terms of y. So the first thing I need to do is get rid of the fraction. I dislike fractions just like most of you probably do. So whenever I can get rid of them. So I just need to multiply by the denominator on both sides. So I have x times y minus 1 equals y plus 5. Because these are going to cancel out. Okay. Now I need to get this y out of the parentheses. So the only way I can do that is by distributing the x. So we have x times y minus x times 1, which is just x, equals y plus 5. Alright, and now we have two terms with y in them. I need to get those on the same side. So I'm going to go ahead and move the xy. So I'm going to subtract xy from both sides. So these will cancel. On the left side, I'm just left with negative x equals. On the right side, I have y minus xy plus 5. Okay, and I just want to keep only my y terms here. So I'm going to get rid of that 5, subtract it from both sides. So negative x minus 5 equals y minus xy. And remember those two examples I went over in your literal equations when I have two terms with the thing I'm solving for. So y, I'm trying to isolate for y. So I'm going to use factoring. I'm going to take out the y. In this very first term, if I take out a y, I'm just left with 1 minus here, if I factor out a y, I'm left with x. And remember, if you want to check this, just use your distributive property of multiplication. Y times 1 is y. Y times negative x, negative xy, so it checks out. Alright, on the left I'm still left with negative x minus 5. Okay, so now I've got my y alone. I need to divide by the 1 minus x on both sides. So here this will cancel, and we're just left with a y. On the left side we've got negative x minus 5 over 1 minus x. This is good. We could write it in a better form, but for now you can leave it this way. And then remember, our next step is to rewrite it. Instead of y, we're going to write f to the negative 1 of x, because that's our inverse notation, is equal to negative x minus 5 over 1 minus x. Alright, and inverse notation, f to the negative 1 of x, super important. Alright, what I want you to do now is work through these 4 problems on the next page. You can check by graphing in a calculator, so you can use your graphing calculator, or if you have the graphing calculator app on your phone, remember you can use that, and that's called Wabbit EMU. So it's on the syllabus, but in case, Wabbit EMU, and that's only going to work for Androids, but it's a free app that looks exactly like our calculator, and you will choose the TI 84 option so that you can practice exactly what you'll have on the tests and quizzes. Okay, so go ahead and do these 4 examples.